Welcome to episode 51 of our Explainer series. Today, we're unpacking rules as code and the Accord pipeline. We are diving into a really fascinating, honestly kind of unavoidable modern clash: the intense friction between the nuance of human law and the strict, totally unforgiving literalism of machine execution. So how do we actually translate our societal intent into executable computer code without, completely losing our legal guardrails? Let's find out.
Here is our roadmap for today. We'll be hitting 1. The limits of literalism. 2. Extracting deontic logic. 3. The rise of computable contracts. 4. The Accord project pipeline. And finally 5. Where human intent meets machine.
All right, starting right off with Section 1, the limits of literalism.
We have to start by acknowledging a massive divide here, what researchers call the modality gap. It's this fundamental disconnect between how we think and how a computer operates. On one side, we've got human law, right? It's purposeful, it's context-dependent, and it's evaluated by reasonable people who weigh actual real-world consequences. But on the other side, we have machine code. Hardware demands absolute discrete literalism. There's literally zero room for nuance. And let's be real, humans are historically terrible at writing perfectly clear contracts to begin with. So when our inherently murky words hit the pure logic of a processor, they basically hit a brick wall.
And this perfectly illustrates why we can't just toss probabilistic AI at the problem and hope it bridges the gap. Noam Chomsky really hit the nail on the head here. AI systems, at their core, act as pattern matchers. They totally lack true working memory or non-sequential planning. Without a strict framework, an AI is incredibly prone to hallucinations and a phenomenon called fax-machine decay. Basically, the system loses fidelity with every single copy, just trying to guess the most probable next word rather than enforcing exact legally binding facts. It's a disaster waiting to happen for contracts.
So how do we fix that? That brings us to Section 2, extracting deontic logic.
The million-dollar question is how we formalize rules without losing that essential human nuance. Enter the rules as code movement, or RAC. The beauty of RAC is that it tells us we actually don't need to encode abstract legal philosophy or heavy theoretical debates into a machine. We don't have to teach a computer what justice is. Instead, we just need to extract the explicit, functional, logical structure that's already written right there on the face of the text.
To do this, legislative drafters rely on something called deontic logic. It maps legal norms into 3 incredibly simple modular blocks: obligation, mapped as must, prohibition, mapped as must not, and permission, mapped as may. It's almost like building with logical Lego blocks. By strictly restricting our terms to these 3 expressions, we completely bypass the complex, swirling ambiguities that usually trip up automated reasoning systems.
Which unlocks our next topic, Section 3, the rise of computable contracts.
By isolating those specific obligations and permissions, we unlock computable contracts. These allow the involved parties to literally translate their contractual criteria straight into computer-processable rules. Think about what that means. We can completely automate prima facie compliance assessments, checking electronic payment deadlines, evaluating when a contract option expires, all of it handled automatically. By giving the computer these clear-cut functional instructions, we significantly drop the transaction costs associated with just monitoring a deal. Plus, there is a fantastic secondary benefit here. By forcing our agreements into a finite state machine model, which basically means the contract can only exist in clearly defined pre-approved statuses, sort of like a digital traffic light, we impose a massive amount of normative discipline on ourselves. Every single event has to be explicit. It totally eliminates those sloppy agreements to agree we see all the time, simply because the computer refuses to accept vague promises.
Let's look at how this is actually built in Section 4, the Accord project pipeline.
We're going to look at a robust open-source framework called the Accord project. Now, understanding this specific triad is kind of the ultimate aha moment for this whole technology. The pipeline leans on 3 distinct yet totally intertwined modules. First, you've got Cicero, handling the natural language text template. Second is Concerto, managing the rigid data schema. And finally, Ergo, which is the domain-specific language that executes the actual hard logic.
When we look at a payment contract built this way, you can clearly see how Cicero's variable tags seamlessly bind the human-readable text directly to those strongly typed Concato variables underneath. This is absolutely vital. It ensures that if an AI agent is interacting with the contract, it physically cannot mistake a decimal number for a calendar date. The underlying data model firmly, mathematically prevents it.
The data transforms through a very deliberate pipeline. It starts with standard common mark syntax, dynamically adds variables in Cicero mark, embeds the JSON logic via template mark, and then finally resolves into an executable agreement mark structure. So step by step, it safely translates a lightweight, totally human-readable markdown file into a fully executable, computationally verified digital agreement. It's brilliant.
Moving to our final part, Section 5, Human Intent Meets Machine.
Let's talk about the profound societal implications here. By defining explicit relationships between, say, a buyer, a seller, and a monetary amount, the Accord pipeline acts as a sovereign gate. It forms the strict semiotic bridge, where our human intelligence and our specific legal intent are safely compiled right into the predictable, deterministic behavior of the processor. We are essentially stewarding the machine.
Because without this incredibly specific text-based architecture enforcing what we actually mean, we leave ourselves wide open to moral crumple zones. It's a terrifying concept, right? These are situations where responsibility gets completely obscured by the sheer complexity of the machine, leaving innocent humans to basically absorb the impact every single time a probabilistic AI system makes a statistical error.
So I want to leave you with this final, somewhat provocative thought to ponder. If we just blindly rely on automated systems without maintaining a strict semiotic bridge, who truly takes responsibility when the algorithm gets it wrong? Thanks for joining me on this explainer, and keep questioning the code.